Hey guys, so today we're starting a new topic and a new set of notes, and it is on something called dimensional analysis. Now, at this point in your science experience, you've probably never heard of the word dimensional analysis before, and that's okay. You've probably heard of unit conversions though, maybe in Earth and space science, or maybe from middle school. You had to do problems where you convert from one unit to another unit. That's just a simpler kind of term than dimensional analysis. And I put on these notes that they are also called turtle problems, and that is kind of a nostalgic thing for me. In the middle of these notes, you're actually going to do a little activity that has to do with turtles. And it's the same kind of activity that I did when I was in high school, and it also taught me how to do dimensional analysis. And for that reason, my high school chemistry teacher called them turtle problems. I didn't know that the word dimensional analysis was a thing. I got to college and I started talking to people about turtle problems, and they looked at me like I was crazy. Okay, so I still lovingly call them turtle problems because of habit, and it seems a little bit less intimidating when you do that. But recognize that the correct terminology is dimensional analysis, and while you can call them turtle problems in here and people will know what you're saying, outside of this class, probably not. Okay, so that's why you've got so many different names up here. But the most correct terminology to use is dimensional analysis. Okay, so as we talked about in the last couple videos, we're going to be taking a lot of measurements in chemistry, and we learned about significant figures, how to round those numbers off when you're doing calculations and things like that. But this is the first time we're really doing calculations, okay? If I take a measurement or am given a value in one set of units, maybe that isn't always helpful to me, and I need it in a different set of units, okay? This is how I deal with that. So this first example, and really all of the examples on this front page, have nothing really to do with chemistry yet. They're just basic everyday life things that you might come across, but you can view as a dimensional analysis problem. Okay, so we're not even getting into the chemistry yet. We're just talking math here. So this first example is pretty simple. It says your boss asks you to pick up 2 dozen donuts on the way to work, but the store only sells by the donut. How many donuts do you need to buy? Now, I'm sure that most of you guys are thinking in your head right now the number. You're like, why do I have to do a calculation? Well, sometimes if you see a calculation done on a very, very simple problem, then it kind of sticks with you better because you're seeing the end result as you work it out. So for each of these problems, you're going to use to your advantage the facts that you know, okay? So we are starting with 2 dozen donuts, and we want to end up with just plain donuts in the end. Do you know any facts about how to convert dozen donuts to donuts? Do you know how many donuts are in a dozen? Yeah, you do. You know that connecting relationship. So I'm going to write down, I know that there are 12 donuts and 1 dozen donuts. Oops. Excuse me. And that is something that is never going to change. That is a fact, okay? We call these things that we know, equivalence statements. This is equivalent to this. 1 dozen donuts can be written as 12 donuts, and it will mean the same thing, just different units. So now I know the kind of linking, connecting idea between this unit of dozen donuts and just plain donuts, and I can use it to my advantage. So I'm going to start with what I was given. I know that I need to collect 2 dozen donuts. That's what my boss said. But I want to convert this unit into something else. Okay? I want to convert dozen donuts into just plain donuts. And how do I do that? Well, I do it with unit cancellation. Okay? I know right here this fact, this equivalence statement, and I'm going to take it and make it into what we call a conversion factor. Okay? So I'm going to do 12 donuts over 1 dozen donuts. Now, if you look right here and you look at the top of the fraction and the bottom of the fraction, this is the exact same thing that we said in our equivalence statement. We know that they are equivalent to each other. So when you take that and make it into a fraction to be multiplied by, that's when it's called a conversion factor. And then let's think about what this conversion factor is saying. We know that these are equivalent, right? I could write 1 dozen donuts as 12 donuts, and they would be exactly the same. So what does this really mean? What am I really doing? What number is this? What fraction is it? It's not just 12 over 1, right? Because the units are different. What kind, I'm sorry, there's a flag going across the screen. What kind of number do you have when you have something in the numerator that is equivalent to what you have in the denominator? Like 3 over 3, or 7 over 7, or pi over pi. Is 3 not equivalent to 3? Is 7 not equivalent to 7? Is pi not equivalent to pi? What number is that? It's 1. Okay? So the only thing that we're doing right here is multiplying 2 dozen donuts by 1. When you multiply something by 1, does that change the actual number? Does it change the meaning or the value that you had? No. In this case, the final answer will change, of course. The number will be different, but that's only because the units are changing. Okay? So we can go through and multiply this by whatever conversion factor we want. Of course, some of them are going to be better and some of them are going to be worse, but as long as I keep multiplying by these clever forms of 1, I will always get something that ends up equivalent to this original 2 dozen donuts. Okay? So let's take a look at what kind of happens here. You guys know from experience that whenever you multiply fractions, right, you just multiply all the numerators together and multiply all the denominators together. So this is really going to be 2 dozen donuts times 12 donuts over 1 dozen donuts. Okay? All the numerators multiplied, all the denominators multiplied. Now, the fun thing about fractions is that if you have a common factor on both the top and the bottom, you know that they cancel, right? So I can cancel this dozen donuts with this dozen donuts, and then I'm just left with 2 times 12 divided by 1, which is how many? 24. And what are my only units left over? Donuts. So I converted dozens of donuts into donuts using this notion of a clever form of 1, this conversion factor from my equivalence statement in dimensional analysis. Okay? So all of your problems are going to be set up this way. You're going to take the units that you're starting with, figure out what equivalence statements you need, convert them into conversion factors, use them in the right way, right? Would it have made sense for me to put 1 dozen donuts over 12 donuts? The answer is no, because then I would have had 2 times 1 dozen donuts squared over 12 donuts, right? My units wouldn't have canceled. I want the units that I want to get rid of to end up on the bottom so that they cancel out with what I had on the top, okay? So you're gonna kind of get used to that and keep that in mind as we keep going. And I think I'm gonna go ahead and stop this video right here. I'm sorry it took so long to get through one, but if we go through a simple example like this and you really, truly mathematically understand what's going on, it's going to make all of these other examples so much easier.